Algebra 1. This is a review for your last quiz of the year based on test 20. So I'm just going to go through each of these problems and how I would go about doing them. You might have done them differently, but we should still arrive at the same answer. Number 1 says the area of a rectangular carpet is 54 square feet. The length is 3 feet more than the width. What are the length and width of the carpet? Well, what I would do here is basically set up an equation. We have this rectangle that has an area of 54 and its length is 3 feet more than its width. Well, if I represent the width by x, then the length is x plus 3. So if I want to find the area, I would be doing x times x plus 3, giving me 54 square feet. Well, I need to solve this, so I expand and say x squared plus 3x, and then I'm going to subtract 54 from each side to get this equal to 0. What this allows me to do is have a quadratic equation that I can factor to say, all right, what multiplies to negative 54 but adds to a positive 3? Well, I would get x and then plus 9 and x minus 6. Well, from here then I can say this side can equal 0, so x plus 9 can equal 0, or this side, x minus 6 can equal 0, because using the zero product property, we know that either one of those could possibly be 0 since they're multiplied together to get 0. So I solve and say x could be negative 9 or x could be 6. Well, it doesn't make any sense to have a side length of negative 9, so we say that our width here is 6, and if our width is 6, then our length is 9. So we would say that our width is 6 feet and our length is 9 feet. Okay, now with a quadratic again, we want to graph the function y equals x squared plus 2x plus 1. Well, let's go ahead and find a bunch of things about this, like where is the axis of symmetry by doing x equals negative b over 2a. So I plug this in and say negative b is, well, it comes from this 2 right here, so negative 2 over 2 times a, well, we have a as 1 in front of that x squared, so we have 2 times 1. It simplifies to just negative 1. So that's my axis of symmetry, that when I graph it, what we are saying here is that I have this line, this axis of symmetry here at negative 1. So let me add that right here. From here, after I know my axis of symmetry, I can find my vertex by plugging in this negative 1, since my axis of symmetry always goes through my vertex. So I plug it in and say y equals negative 1 squared plus 2 times negative 1 plus 1. And I simplify and I have negative 1 squared is 1 plus 2 times negative 1 is a negative 2 plus 1. Ends up coming out to be, of course, 0. So that means that my vertex is at this point of negative 1 comma 0. X as negative 1, y as 0. So I have the point, my vertex, right here. All right, the next thing that we find is the y-intercept. And the y-intercept is always found by my c value, which is plus 1. So I have a y-intercept of 0, 1. So I'm going to plot that right here on my coordinate plane. I'll make this a little bit bigger. And then I'm going to flip it over the axis of symmetry, which means if we're 1 unit away from the axis of symmetry, I'm going to go across the other way to make it symmetrical. After this, we have a view of what it is starting to look at, but we want one more point. So I'm going to plug in x as 1, just a simple number to see what else is going to happen. I plug it in to find y to get 1 squared plus 2 times 1 plus 1. That's 1 plus 2 plus 1 is y equals 4. So I have this point at 1, 4 that I can plot now, 1, 4, and then push across my axis of symmetry. So I can now see that this is my parabola. Okay, that's all we need to do to graph our quadratic equation. Okay, let me get myself some room to do number 3 here. And we need to divide these two rational expressions here and simplify as much as possible. But remember, with fractions, if I'm dividing, I'm going to copy the first one, m over x, and multiply by the reciprocal. So we're going to flip the other one to say m plus x over n. And in this case, I don't see anything that I can simplify beforehand. Remember, this x and x can't be simplified because of that addition sign. And so we just go ahead and multiply. So denominator is easy. We have xn. And then remember, with the numerator, I have to expand out. M needs to be multiplied to both of those parts. And we get m squared plus mx. Okay? With this, you could have kept it as its factored form of m times m plus x over xn. But in both of these cases, we need to remember to exclude some values. We have to say x and n cannot be 0. All right, number 4, I need to expand these radicals and simplify. So I expand them, and root 2 times root 10 is root 20. I'll simplify that in a minute. And then minus root 2 times root 6, which is root 12. Well, we split these into their prime factorization to say 20 is 2 times 2 times 5, and root 12 is 2 times 2 times 3. Well, I can circle and pop a 2 from here to get 2 root 5 minus, circle and pop, 2 root 3. Since these radicals, root 5 and root 3, are not the same, I actually have to leave it as just 2 root 5 minus 2 root 3. All right, find the distance between the points 6, -4, and 1, 1. Well, I don't have to graph this actually. I just need to use my distance formula of the square root of x1 minus x2 squared, so the difference in the x's, plus the difference in the y's, y1 minus y2 squared. So I plug in and I say, let's say that my first point, 6, -4, is my 1's, and 1, 1 is my 2's. So I'm going to say x1, which is 6, minus x2, which is 1, squared, plus y1, which is -4, minus 1 squared. And let's simplify. 6 minus 1 is 5 squared is 25, plus -4 minus 1 is a -5 squared, which is also 25. So I have the square root of 50, which when we simplify it using the same method that I did up here, we would get 5 root 2 units. All right. Determine whether the graph of each function below opens upward or downward. Well, the only thing that tells me if it opens up or down is if it's a negative x squared or a positive x squared. And so I don't really care about the 4's. I really just care if it's positive or negative. And so if it's positive, it opens upward. And if it's negative, it opens down. Now, just a little hint here, sometimes you'll see things like this. 2x squared minus y equals 5x plus 3. And you need to get y by itself by subtracting 2x from each side, getting negative y equals negative 2x squared plus 5x plus 3, and then we have to divide by -1 to get y by itself. This ends up that we have y equals a positive 2x squared minus 5x minus 3. This is the only way. We have to get y alone. This is the only way that we know that this one opens upward. Okay, if this were a similar problem that maybe even said something like plus y instead of minus y, and we had a positive y to end with, something like this, then we would say this opens downwards, downwards because we have a negative 2x squared. So it all depends on when y is by itself and everything is on the other side. Okay, solve the equation below by graphing the related function. There's lots of ways to solve this, but this wants us to graph it, so we will. And just like we did on the other side, I first have to find the axis of symmetry, which comes from x equals negative b over 2a. Since I don't see just a x value here, that means that my b value is 0. So I have negative 0 over 2 times 1, which is just 0. I plug that back in to say that, and you can think about this 0 as a y. So y equals x squared, so 0 squared minus 9, so y is negative 9. Meaning that when I go over here, I'll erase this. When I go over here to plot my equation here, I have my axis of symmetry at 0. So I'll just put it really close here so you can kind of see it. And then we have my vertex at 0, negative 9. So I'm going to plot that right here at negative 9. Then we go back and find our y-intercept and realize that our c value of negative 9 is the exact same as our vertex here. So we try something else. And we are going to plug in a couple more values. Let's say I plug in x equals 1 and x equals 2. Something like that should give me a good idea of where we're ending up. So if x equals 1, I'm going to plug it in and say 1 squared minus 9 gives me my y value at negative 8. So I have a point here at 1, negative 8. And so I plot that 1, negative 8 and put it across the y, or the axis of symmetry. All right, let's see when x equals 2. And I say 2 squared minus 9 equals, well, 4 minus 9, so negative 5. So I have a point at 2, negative 5. All right, so 2, negative 5, and flip it across the axis of symmetry right here. Now, I'm not super close to this y-intercept yet, or sorry, not the y-intercept, the x-intercept, which is our solution. So I could extend this, but I'm not for sure that I've extended it correctly. So I'm going to wait. Let's plug in one more value to see if we can get closer, like x equals 3. And I get 3 squared minus 9, which is just 0, meaning I have a point at 3, 0. This is actually a really good thing because these are my solutions. We have found exactly where it goes across that x-axis. So we have found our solutions at 3, 0 and negative 3, 0. Okay. Determine whether the ordered pair 0, 1 is a solution of the inequality. Well, the only way to do that is to plug it in. And so we say y is 1, and is that greater than 3 times 0 minus 2? So is 1 greater than negative 2? And we would say yes, it is a solution. All right, factor the polynomials. Well, when I look at this first quadratic, I see a negative x squared. That's not super easy to deal with, so I'm going to factor out a negative 1 first and say x squared plus x minus 12. And I'm going to factor this inside part. Well, that's just a simple quadratic where I say I want to multiply to negative 12 but add to a positive 1. That gives me x plus 4 and x minus 3, and that is my factored form. All right, next one I look at and I see that I have 4 terms, which means I'm probably going to have to end up factoring by grouping. But let's see if there's a greatest common factor first. And we see between 24, 24, negative 18, and negative 18, a 6 could come out of all of those. And they all have some a's in common. They actually have a squared in common. But they don't all have b's, so I can't take out a b. But I can take out that 6a squared and say that I have left 4ab plus 4a minus, oops, it should be a 3b minus 3. Okay, and then from here I can factor by grouping by saying I'm going to factor these first 2 terms to say I have 6a squared times 4a is in common between them, so I have a b plus 1 left over. And then I'm going to factor the second 2 and say that I have a negative 3 from each of them with a b plus 1 left over. Well, that b plus 1 is in common, so I can factor that out of each of these bigger terms to say I have b plus 1 times what is left over, 4a and a minus 3, 4a minus 3. And that is our factored form by using greatest common factor and factoring by grouping. All right, number 11. It takes Anne 3 hours to rake a yard. It takes Linda 2 hours to rake the yard. How long will it take them if they work together? Well, this is one where we say I have 1 whole yard to rake, and we have to look at how much each of them can rake in an hour. So basically we're saying for Anne, she can rake 1/3 of a yard in an hour. Because it takes her 3 hours, every hour she rakes 1/3 of the yard. For Linda, she does it in 2 hours, so that means in 1 hour she can rake half of a yard. Well, I could simplify this a little bit and just say that their situations are Anne has x over 3 and Linda is x over 2. Since I want to basically have them work together, I'm going to add up their different work times so that I get a total of 1 yard raked. From here, I can simplify these fractions. I'm going to get common denominators of 6. So I multiply the first one by 2 over 2, second one by 3 over 3, and I get 2x plus 3x over 6 equals 1, which means that I actually have 5x over 6 equals 1. You can multiply by 6 on each side, or you can multiply by the reciprocal here of 6 over 5 and get x equals 6 over 5, which means that it's going to take 1 1/5 hour for them to work together to actually get this yard done. Okay. Find the axis of symmetry for the quadratic function. All right, well, axis of symmetry is just that negative b over 2a that we've been working on. And so we say that b is -6, so I have a -6 over 2 times a, which is -3. And so this -6 is a +6 over a -6, meaning that my axis of symmetry is -1. But this is the equation of the axis of symmetry, so I say x equals -1. All right, 13. Find the side length to the nearest tenth. Well, that means that I have to put it in the Pythagorean theorem to say 3 squared plus 5 squared equals my t squared or c squared, however you want to do it. And so I have 9 plus 25 equals t squared. And so that is 34 equals t squared that I take the square root of. Well, square root of 34, that's between the square root of 36 and the square root of 25. Those are my whole numbers of 5 and 6. But it's pretty close to 6. The square root of 34 is much closer to the square root of 36. So maybe I estimate that it's something like 5.7, or maybe 5.8, or maybe even closer, 5.9. Well, you would multiply each of these out to see which one is actually closest to 34. When you do this, and I'll just use, just for sake of time, I'll calculate, and we have 5.7 times 5.7 gives me 32.49. And then 5.8 times 5.8 gives me 33.64, definitely closer, and 5.9 times 5.9 gives me 34.81. This one is off by 81 tenths or 81 hundredths, and this one is only off by 36 hundredths, meaning that 5.8 is the best estimate for that. So we would say 5.8 units is the side length to the nearest tenth. All right, let's finish this off pretty quick. We're getting down to just some simple equations. So solve the equation, and I have to get the absolute value alone first. So I am going to subtract 4 from each side, and I get 3 times the absolute value x over 6 equals -2. And then I see this 3 and 6 can simplify to a 1 and a 2, which means I'm just going to multiply by 2 on each side, and I get absolute value of x equals -4. Well, if we're talking about absolute value is talking about a distance. So how can I have a distance from 0 that is negative? That's not possible, and we actually say there is no solution, because nothing that I put in here for x will ever come out as a negative number. All right, divide x squared minus 10x plus 25 by x minus 5. There's a lot of ways to do this. I am going to show our box method, but just know this one's going to come out nicely. So if you wanted to factor this first and then divide, that would actually work quite well. But if I use my box method to divide this, I'm going to say one of my side length is x minus 5, and I'm trying to discover this other side length. The area is x squared minus 10x plus 25. And I start with my x squared here, since I can do x times x giving me x squared. And then I fill in what I know. This side length is x by negative 5, so I get a negative 5x. But I need a negative 10x. Well, the only way to get to a negative 10x is by having another negative 5x. Well, we have the x from this side length, so this side length must be a negative 5. And then it turns out that negative 5 times negative 5 is 25, which is exactly what we need here. So we have our area of x squared minus 10x plus 25, and we see that our other side length is x minus 5, which means this division problem comes out as x minus 5. Number 16, multiply together. Well, what I would do first is actually factor and see if there's anything I can simplify. And in this first numerator, I can factor out an xy. So I have 4x plus 1 over 9x plus 15 over, well, I can factor out a y to get 4x plus 1. And we're multiplying these together. So that means that I can simplify across, and this 4x plus 1 is the same as this 4x plus 1. This x right here simplifies with this x down here. The y and the y cancel out, and then the 15 and the 9 simplify by 3's, and so our final answer is extremely simple of 5/3. Number 17, we need to add these together, and what we see here is we don't have our similar denominators, so I'll factor the denominators first to say this is actually 3x squared over x minus 3 times x plus 3, just our difference of squares formula, plus x minus 2 over 2 times x minus 3. Well, we want a common denominator that satisfies all of these and is similar to what we already have, which means I need to represent this 2 in the denominator, I need to represent this x minus 3, and I need to represent the x plus 3. So in order to get to that denominator, this first one has to be multiplied by 2 over 2 to get us a 6x squared. And the second one here needs to be multiplied, well, it's missing this x plus 3. So I multiply by an x plus 3 over x plus 3. So in that numerator, I have to actually expand these two binomials. I'm multiplying together x plus 3 and x minus 2. And I do some rainbows and smiley faces, ends up that I am adding together x squared plus x minus 6 when you actually expand the 3x and the negative 2x and simplify together. All of this can be simplified just a little bit more by adding together this x squared and 6x squared, and so I am going to say that is a 7x squared. And that numerator can't be factored anymore, so we will leave it just like this. All right, last 3 here. I need to expand out both of these sides first and then simplify. So 3x minus 12 minus x is greater than 8 minus 8x, and then negative 2 times negative 5 is a positive 10. Simplifying each side, 3x minus x is a 2x minus 12 is greater than, well, 8 and 10 give me 18 minus 8x. I need to get all of my x's to the left side, so I'm going to add 8x to each side. And I get 10x minus 12 is greater than 18. Add 12 to each side and get 10x is greater than 30. And divide by 10 to get x is greater than 3. Now it also asks us to graph this, so on a number line we would have 2, 3, and 4, open dot on 3 going to the right. All right, let me just erase this a little so I can see what's going on in this next one. We actually have 2 different inequalities here, but I'm going to simplify the inside part first to say I have negative 4 is less than, well, x and 2x give me 3x plus 5 is less than or equal to 11. I'm going to split these into their 2 parts. This first inequality, negative 4 is less than 3x plus 5, and the second inequality, 3x plus 5 is less than or equal to 11. Solve them in the same way by subtracting 5 and dividing by 3. So on this first one, subtract 5, divide by 3 gives me a negative 3 is less than x. The next one, subtract 5, divide by 3, we get x is less than or equal to 2. Well, I can see that this is a compound inequality that I can squish back together to get -3 is less than x, which is less than or equal to 2, which on a number line is going to look like a -3 and a 2, open dot on -3, closed on 2, and connecting in the middle. All right, last problem here, absolute value of x divided by 3 is greater than 1. Well, I have to get the absolute value of x by itself, so I'm going to multiply by 3 to get absolute value of x is greater than 3. I split this into two different inequalities. I say x is greater than 3, and then I use the opposite of all of this. X is less than -3. And then, since these are actually already solved for x, I can go ahead, let's see what happens on a number line with -3 and 3. Well, this x is less than 3 has an open dot on x going to the left, open dot on 3 for this other one going to the right. So this is a disjoint inequality, so we can write it with an or in between here. All right, so that is the end of the review. I hope this helps you understand some of these problems a bit better and review and study for your test or your quiz on Friday.